Hello again. In this question, we are given that a stationary source emits a sound of frequency 492 Hertz. So, the source is stationary. From here, it is emitting a sound of frequency 492 Hertz. The sound is reflected by a large car approaching the source at the speed of 2 meter per second. So, this car is approaching this source at 2 meter per second. So, sound is reflected from the source, right, and that sound goes back to the source, and it is given, you have to find the beat frequency of the resulting signal, right. So, let's first find out the frequency with which this car will receive the sound that is being emitted. So, we find the frequency received by this car as it approaches this source. So, you know that frequency is equal to the original frequency into speed of sound plus minus the speed of observer. Since the observer is moving towards sound, you will have plus 2 divided by the speed of sound because the source is stationary. So, this is the frequency that will be received by this car. Now, this car becomes a source of this frequency, right. So, the frequency received by the source again will be equal to the original frequency, which now becomes this value, because this is the original frequency for this new source, right. Call it S dash now. The car is now the new source. Once when the signal is being reflected, the car is the new source of that reflected sound, right. So, nu naught into C plus 2 by C into, now in the numerator you will only have C because the observer now is not moving, because this original source is now the observer, divided by C minus 2 because the source is moving, right. So, this tells you that it is equal to the original frequency, which is given to be 492, and you are given that speed of sound is 330. So, C cancels out, you have 492 into 332 divided by 328, right. This value, if you calculate, will turn out, so you can clearly simplify this with 82, right. This will be 123, and further simplification should give you the value. You have to find the beat frequency. So, let's try to simplify this. You have 82, so this will be 41, this will be 166. So, this will go with 3. So, you have 6 3s 18, 19 and 498 Hertz, right. So, this is the frequency that is received back by this source. Now, the original frequency was 492, what is received is 498. So, the beat frequency is clearly magnitude of 498 minus 492, which is 6 Hertz. So, this is the beat frequency.